Arrival. Good morning, everybody. Thank you.
Ecco, oggi
Today, I'm going to talk about the strategies to improve graft survivals. This is something that we have been studying in the last 2 years in Liverpool. This is graft survival in UK after 5 years, 72%. So how can we improve this survival? What are the possible strategies? So we have studied the management, the corneal revascularization, in particular surgically, and the sequential graft and gene matching. So because the corneal revascularization is associated with the loss of vision, and in particular is associated with graft survival in most indications. It is to be found, in particular the ones you may see here in red on the right-hand side. We know that the imaging of this revascularization cannot be properly seen with a slit lamp because we get no signs as to the architecture of the revascularization, so we prefer to use fluorescein to actually identify the anatomy in green of the revascularization. So the following step is certainly going to be the use of OCT angiography, which will tell us how if there is a revascularization in a non-invasive way. So what to do? And what is most important is to remove the cause. And most comments are that revascularization comes back. But this is probably due to the fact that we aren't able yet to really remove the basic cause. So it depends on the pathology. Very often we have herpes at the basis. So removing the cause is the best angiogenic treatment. Then we have medical treatment or surgical treatment. When to go for it? Revascularization in an early stage is quite useful because at the beginning we are not able to keep the infection under control. So most of the times we do need revascularization, but at other times, when the patient is being treated for the specific kind of infection, that's an example, then an anti-angiogenic treatment with steroids or anti-VEGF should be initiated. Then we have a stabilization period where parasites surround the vessel. At this point, revascularization does not respond any longer to medical treatment and surgery is needed. This is an example of an angiography. This patient was treated only by removing the cause, so by means of antimicrobials, and there is a reduction of the revascularization. As I said, this is the best possible angiogenetic treatment. This is the finding when only the afferent vessel is treated. So, and the reduction is sizable. So we know that the number, and the density is associated with a better graft survival. So, and we have associated this large diameter graft, and we have noticed that the larger the diameter, or say the opposite, the less large the diameter, the better the survival of the graft. So this is a sequential graft.
che hanno
In Fuchs dystrophy and keratoconus, if the grafting has been performed on the second eye, when in the first eye the graft is still clear and functional, there is a reduction by 50% of the graft failure risk, and this regardless of the grafting timing. In Fuchs dystrophy, it is even more clearly so, and this is a retrospective study but the findings are extremely significant. Then we have gender matching. So this is a male to male and a female to female, I mean donor and recipients. So folks in women, we may have a 50% reduction, and the keratoconus 20%. And also HY matching, which means that the HY are proteins which are recognized by T4 cells, lymphocytes, and may trigger an immune response. And in folks, we have a reduction of the graft survival if HY is associated 20 to 40%, and keratoconus by 30%. So we have concluded that HY mismatch. So never. So there should be never a graft from a male to a female. So this, the matching is very important to reduce the corneal revascularization, and then the diameter of the graft matters, and we should avoid the gender mismatching. In this way, we can reduce graft failure in a range of 20 to 40%. We have just initiated a multi-center study in various countries in order to confirm these findings. Although these findings have been obtained on about 18,000 grafts. I wish to thank SICSSO, the Liverpool University, and also Fight for Sight for the funding, and also the Venice Eye Bank that has provided to us all the necessary corneas.